Today we are continuing, starting on page, I believe, 95. We are starting on page 95, and we're going to read to 98. Chemical bonds. The forces that hold together the atoms in molecules are called chemical bonds. Chemical bonds form because of the attraction between positive and negative charges. Atoms form chemical bonds by either sharing or transferring valence electrons from one atom to another. Valence electrons are those electrons in the outer shell, so the outer orbital of an atom. So chemical bonds form on the valence shell, called the valence shell. It's the last shell of the atom. If each orbit can hold only a certain number of electrons. If the valence shell is full, then that atom will not react with another atom. Well, actually, it could still react. It will not. The valence electrons means it's full. Now, it can give up an electron or it can share an electron, but the valence shell is full. That atom is pretty much what they call stable. Valence electrons from one atom to another are involved in transferring or sharing those electrons. Variations in the forces that hold molecules together are responsible for a wide range of physical and chemical properties. As shown in figure 3, there's a model there, a physical model of a molecule. Scientists can study interactions of atoms to predict which kinds of atoms will form chemical bonds together. Scientists do this by comparing the number of valence electrons that are present in a particular atom with the maximum number of valence electrons that are possible. For example, a hydrogen atom has only one valence electron. But because hydrogen can have two valence electrons, it will give up or accept another electron to reach a more chemically stable state or unreactive state. Remember, because the valence electron, if there's any one valence electron, if that outer shell is not full, then that atom will react with another atom. And this can be good and it can be bad, depending on the type of reaction. So there are what's called two types of bonds. An ionic bond, that's when an atom will give up or accept an electron. And then there's something called a covalent bond, where the atoms will share electrons. So an ionic bond, there is a transfer of electrons, and then a covalent bond is a sharing of electrons. So, and we're going to go to page 96, and we'll talk about ions. When in definition of an ion here is an atom or molecule that has gained or lost one or more electrons and has a negative or positive charge. It's called an ion. Remember, atoms are usually, the periodic table, we have atoms that are normally in a stable state. Alright, so they're usually written in a stable state. Ionic bonds, the attractive force between oppositely charged ions, which form when electrons are transferred from one atom or molecule to another. So these ions can be positive or negative, and they will either attract or give up electrons. A particle, when an electron is transferred from one atom to another, both atoms become charged. That means they either have a positive charge or negative, depending on the number of protons in the nucleus. If the electrons are more than the protons, then there's going to be a negative charge on the atom. If the protons are more than the electrons, then it's going to be a positive charge. And this is going to determine the attraction between electrons. A particle, such as an atom or molecule that carries a charge, is called an ion. Neutral sodium atoms have 11 electrons. And because a sodium atom has one valence electron, sodium is a group 1 element on the periodic table. So if a sodium atom loses its outermost electron, the next 8 electrons in the atom's electron cloud become the outermost electrons. Because the sodium atom now has 8 valence electrons, it is unlikely to share or transfer electrons and therefore is stable. So one of the things that we should understand that an atom wants to be stable. It wants to be stable. So that's why in chemical reactions you either have, they want to give up an electron, share an electrons because they want to be stable. And however, the sodium atom is missing the one electron that was needed to balance the number of protons in the nucleus. So when an atom no longer has equal number of positive and negative charges, it becomes an ion. So therefore we have positive and negative. So and the sodium atom became a positive sodium ion because it is plus. This means it has more protons than electrons. So when the atom released its valence electron, it became positive. It was balanced and it became positive. For whatever reason, it released that atom. So now, suppose a chlorine atom accepts the electron that the above sodium atom lost. A chlorine atom has a total of 17 electrons, 7 of which are valence electrons. So this chlorine atom now has a complete set of 8 valence electrons and is chemically stable. So the extra electron, however, changes the neutral chlorine atom into a negatively charged chloride ion. So therefore now we have an atom, a chlorine atom, now has more electrons and protons, and therefore it is a negative ion. So basically an ion is a charged atom. Ionic bonds. The attractive force between oppositely charged ions that result from the transfer of electrons from one atom to another is called an ionic bond. A compound that forms through the transfer of electrons is called an ionic compound. Most ionic compounds form when electrons are transferred between the atoms of metallic and non-metallic elements. Sodium chloride, or common table salt, is an ionic compound. The positively charged sodium ions and negatively charged chloride ions attract one another because of their opposite charges. This attraction between the positive sodium ions and the negative chloride ions is an ionic bond. The attraction creates cube-shaped crystals, such as in the table salt shown in figure 4.